Good evening. So this is the last session for the day. We'll get started. The title is Living Without Sudo. Okay. So I'm Divya. I'm a software architect at IBM. I work for a product called IBM PowerVC, which is an on-prem cloud solution, and it's built on top of OpenStack. I've been working on OpenStack for 5 years now, and my colleague Abhishek couldn't make it. He's also working for the same product. So what exactly is the background of this session? Just before I start, how many of you already use OpenStack as in contribute or deploy? Could you raise your hand? Okay, great. So as you know, OpenStack services, when you install OpenStack, it's a bunch of services. And each service is started by an unprivileged user. So if you take Nova as a service, Nova is not started by a root user. It's started by a user named Nova itself. And Nova user does not have a lot of privileges. Yeah, so for each user, a separate user is created. And one assumption that OpenStack often or always makes is that the OS user can always be created. So the entire OpenStack is sort of installed, at least in most cases, under the assumption that the operating system is going to allow you to create a local user. At least that's how most of our customers also use it, and I guess that's how most of the industry uses it. Unprivileged service users execute privilege commands using sudo. So when your service is running, let's say Nova service is running and it needs to run a privilege command, there was root trap and there's a lot of work on privsep also happening. And but there's this assumption that the sudo utility is going to be around and you can use sudo to run a command, a privilege command, even if that means to actually initialize privsep. So just a quick slide on Oslo root trap and privsep, but talking or going more in depth around this is not the scope of this session. And you can see a lot of other material on this. But at a high level, root trap is an Oslo library that is used to filter the privilege commands run by each service. So if there was no root trap, then you would have to go and directly edit your sudo file and say that my Nova user has to be able to run all these commands. But now you don't have to do that. Instead, there's a filter file where you specify that, hey, Nova user should be able to run only these commands. So the catch here is that any hacker or unauthorized user who gets control can manipulate this access. And as you know, the Oslo community is moving towards privsep, but there could be a lot of cases where you have OpenStack and you have a lot of tooling around OpenStack. It could be even a new OpenStack service that you have written for your product, or for some reason you have some other things built around it, which is using sudo. So moving towards privsep does not completely solve the problem if you have an environment that does not have the sudo utility at all. So what exactly is the problem or challenge that we are talking about here? So as you know, the importance of focus on security and compliance has really increased in the last 1 year or so with GDPR, that's General Data Protection regulation, coming in effect since May 2018. So customers, especially banking customers and a lot of other customers, they're very focused on security and they want hardened systems. So a lot of times when we work in the community, we work under the assumption that all the things that we think, for example, local users, local groups, sudo utility, is going to be around, it's available. But that might not be the case in a production environment. A lot of times, a lot of hardened systems do not let you create local users, which means that you run the user add command, it's not going to work, or you run the password command, it's not going to work. And there are a lot of environments where there is no sudo. So I'll get to why there is no sudo and what are the other mechanisms that a lot of customers use. So that's where emergence of centralized PAM or PIM solution, that's privilege access management or identity management solution, comes in. So the problem we're talking about here is there are a lot of environments that do not support local users or groups, do not support sudo, and in those environments, is it even possible to install and set up and get OpenStack working? So I'll pause here. Anyone has actually run into this problem or has a customer who does not have any of these? Okay, no one here. Okay, so another problem is that even if the current community, that's master, has a lot of work going on with respect to removing dependency on different things, a lot of times customers are at a more stable version. They are not at Train or even Stein. They would be at least 2 versions behind and probably wait for community to be more stable. And that's when they could make an organization-wide decision saying that, hey, we want to go to a hardened kind of system. We want to use a new privilege access and identity management system. So the question is, without making any changes to OpenStack, with their and letting them continue with the stable version they have, is it possible to set up and move to production with OpenStack? The point here is that when we started off with this effort, we did not find any documentation with respect to OpenStack. I think there was one documentation which said that there is no support of OpenStack with these kind of systems or environments, but there was nothing to help such an environment building. So our basic goal was to validate if OpenStack could coexist in such environments. So goal of this effort is to get OpenStack up and running with a privileged identity and access management solution without sudo or local user or groups, and without having to make any changes to the open source code. So this is what exactly this session covers. It's the experience that we had, and this is more of an experience sharing session. We did not really document this effort, but so I'll get to the environment that we use. So like I mentioned, we had an environment which is not the regular environment. So if you take a regular Linux OS, you have sudo, you have the local configuration files, which basically means that when you talk about sudo, they are the sudoers files. You can also create your own files and put it under the sudoers D directory. You can create users in groups. You can define permission on what a particular user should be able to do. And when you talk about sudoers file, if you have, let's say, 2 systems in your environment, you can, and you want exactly the same kind of privilege access, and you're using sudo, you would basically have to take your files from one system and put it into the other system. Let's say what happens if you have 1,000 systems and you want exactly the same kind of users and same kind of sudo access or privileges for all the 1,000 systems, then you would probably have to add some tooling or mechanism to do that. So sudo's file and sudo is not really built for that kind of scale. It focuses one system at a time, and it does not give you a central control over or granular control over how it should be for each of the system. So this is where comes in centralized solution. So as we went into sudo and local user accounts, it's basically open source, and it's okay for small and medium infrastructure. It does not have a lot of things, like it does not have auditing, so which means that every time you go and make any changes to your sudoers file, it's going to be difficult to figure out who made the change, what exactly is the change, etc., etc. So that's where the centralized solution comes in, which is you can call it a replacement for sudo, but it has central access, which means that if you have like 1,000 systems or a huge scale and you want the same kind of privilege access across all your systems, you will be able to manage that. So this is at a very high level architecture of a centralized PAM solution. So on the right-hand side, what you see is your normal Linux system. And you can imagine it without a sudo utility. So uh, there's typically a non-sudo utility or an agent. And there's a central server. The central server resides outside. So you can imagine one central server and 1,000 Linux systems. And there is, I mean, this might not be the case for all the identity management server. This was the case for the solution that we use. So the solution that we used is called Centrify. I'm not sure how many of you have heard of Centrify, but this is at a high level what would be the case if you look at the architecture. So typically what happens is you have the sudo utility inside the Linux system, you have your users and groups there, but in this case you have a central server and you have a separate LDAP server, and central server is what controls everything. So if you want to say that, hey, I have these 10 systems and I want all my 10 systems to have users A, B, C, D, and A should have SSH access, B should not have SSH access, C should be able to access something else, etc. All you have to do is go to the central server and put all those rules and definitions there, and it gets applied to all the other systems which are managed by the central server. So it gives central access and granular control over what your users should do and how many users should be there. So it's not the case where, and even when you create a file, in the normal case, your file permission maps to your local user. In this case, your file permission maps to the user which is defined by the central server. And the central server in itself does not store all the users and groups, so it needs to have a identity backend to do that. And the standard one uses the LDAP server. So in the experiment that we did, it was a Active Directory. So all the users and groups and the privileges, etc., defined at the LDAP server, and central server is just, it mostly provides a mechanism where you can give all your policy definitions. So what effectively happens is that when you want to run some particular command which needs privileged access, earlier it would go and take the help of sudo utility. Instead, now it goes and talks to the agent, and the agent in turn goes and interacts with the central server and sees if this particular user has the required privilege. So this is at a very high level. So this is again a comparison of the flows. So if you are an unprivileged user, let's say you are NOAA user, and NOAA user wants to do some particular activity, let's say chown. In the earlier scenario, NOAA user would have something defined in the NOAA file which says that, yes, I mean, it could be root trap or some other mechanism, and then the NOAA user uses sudo utility to actually run the command. In the new way of doing things, it does not talk to sudo. Instead, it ends up talking to the non-sudo utility, and then the non-sudo utility, which is also referred to as the agent, talks to the central management server, which has a role definition and figures out if NOAA user actually has the access to do this. So this is a little bit more on the user role definition. So it's again the same thing. On the left-hand side, what you see is your Linux OS with the non-sudo utility. On the right-hand side, what you see is the central access management server. So the way you define is very similar to the way you generally define, which is the role-based access control. You have a role, and you have a user, and you basically define what that particular role can do. So in this case, you have to create a role definition, and role definition basically means that you define what are the different commands or activity that are associated with that particular role. So in this case, if you see its role definition A means, say, command 1, 2, and 3, and then you assign the user to the role definition A. So when that particular user performs a particular command, runs a particular command, let's say it's command 1, the non-sudo utility contacts a central access management server to figure out that, hey, this particular user, user 1, is assigned role definition A. Does command 1 come under that? So effectively, that's how it works. So this is the environment that we used. We used OpenStack with Centrify Access Manager. And Centrify is licensed, which is the reason it's very difficult for the community to actually go and try it out, because Centrify is just an example. There are a lot of other identity and access management systems that are around. So we tried it with a trial license. Like I mentioned previously, the Centrify access, the server is a separate entity. It needs Microsoft Active Directory to be present. So we set up Microsoft Active Directory on a separate server, which is a Windows server. The Centrify Access Manager was also installed on Windows. And it was joined to the Active Directory, where Active Directory itself had the users and groups. And then the OpenStack that we used was installed on RHEL 7, and it had Centrify agent running. So effectively, you can imagine OpenStack running on RHEL 7, and that talking to Centrify Access Manager, which effectively is joined to Active Directory. So this is how a regular OpenStack installation looks like. It's a very simple diagram. So if you imagine one instance of OpenStack with Nova, Keystone, Glance, Neutron, and Cinder, you have a local user, and the service runs, and the service goes about doing things with sudo. Now, this is the architecture of a Linux system which has the access, which has a central access management server. So I've divided into 3 nodes, node 1, 2, and 3. If you see in node 3, that is your Linux system, which is going to have OpenStack installed. So node 3, as you can see, doesn't have any sudo. It doesn't have a provision for local user or group creation at all. All it has is a non-sudo utility. So in the case of Centrify, it's called DZDO, DZ and DO. So the Centrify agent that runs, it connects to the Active Directory, and which is node 2, and node 1 is your central server, which I think I explained that before. So how did we go about with the OpenStack deployment? So now that we are clear about what the problem is, and the fact that we have to go about installing OpenStack. So you can imagine installing OpenStack on a system which doesn't have sudo and which doesn't have a provision for local user and group. It's not going to be installed. Even if it installs for some reason, it's not going to work. So the way we went ahead was that we first preloaded all the services and groups into the Centrify central server. So the first challenge was to figure out all the different users and the user group relationship with respect to OpenStack. So Nova is just one service. There are so many other services, including, say, for example, RabbitMQ for message queue, MariaDB for your database. And even if you take Python dependency, there could be a lot of dependencies which actually goes and create users. So we had to figure out all the dependencies and all the users that need to be created, basically the OS users that need to be created to get the services and the dependencies running. So making that list was the first step. The second step was to go into central server, Centrify central server, and to load all these users and groups. So, it had to be with the same association, as in, if there's a particular group which needed some groups to be available, it had to be done exactly that way. Define commands, second is add role definition and define commands that service user need to access, which basically means that if you take, for example, Nova or Cinder, right now if you go and see, you will see that the sudoers file, it has a definition for root wrap. It also has a definition for, say, privsep helper. So when we did this effort, I don't think Nova was using privsep. We did it a couple of releases. We took a version which is a couple of releases or more back. So the first and the second step, first step was to figure out all the users in group, and the second step was all the sudo dependency that each of the service has. So like I mentioned, a lot of times it's not just the OpenStack dependency. There is also a lot of tooling that you build around it. So you need to figure out all the different commands that your underprivileged or unprivileged user needs to have access to. The third one was to go and add these role definition into the Centrify server. The fourth one is a little tricky. It's actually a hack because what happens is that you cannot go, I mean, there are multiple places in OpenStack code where sudo is used, and it was just impossible to go and change all the places. And if community were to work on that, I mean, Privsep is the work that's going on, but at that time, there were a lot of references. It was just impossible to do that. So the hack we did was we actually created a symbolic link from sudo to the non-sudo utility. So in this case, the non-sudo utility is dcdo. So the good thing that happened was that dcdo had exactly or has exactly the same syntax as sudo. So which means that wherever your OpenStack code runs sudo, if you replace it with dcdo, it works perfectly well. So by creating a simple symbolic link, which is again a hack, we were able to work around the problem of having to replace sudo everywhere because it was not possible to replace sudo. But then you could end up using a privileged access management solution which has an agent which is not dcdo, means if you don't use Centrify, it could be something else. And in that case, you would probably, and it might not have exactly the same syntax. In that case, probably you would have to write some tooling around it or some kind of wrapper so that if you run, when the sudo command gets run, it actually converts it into the same syntax as your non-sudo utility. So this is exactly the same diagram as before, but with the steps that I just mentioned earlier applied. So as you can see, the nodes are same, node 1, 2, and 3. So like I mentioned, the first step is create all OpenStack service users to Centrify Active Directory. And so create all the accounts into the Centrify server. That's the first step. Second is to configure dcdo user privileges. The third one and the fourth one, it basically talks about, there is no sudo, so like I mentioned, we created a symbolic link. So what happens is, if you see, in OpenStack, if a particular service runs a command which needs sudo, it instead goes and, because of the symbolic link, it goes and invokes the non-sudo utility, and then non-sudo utility goes and it talks to the Active Directory and the central server to figure out if the access is there or not, and then it goes about performing the activity. So this is a snapshot of the first step, which is users loaded into the Central Access Manager. So this was actually quite a tedious step because, like I mentioned, we had to figure out all the different users that OpenStack actually creates. So if you see on the left-hand side, that's the user section, and this is a screenshot of Centrify Access Manager. So each of the service, we had to mention it. So you can see it's not just the main services. That we found that a lot of Python dependency also creates user, and we had to identify all that. This is a similar image for the groups. This is the command definition. So like I mentioned, we had to figure out all the different commands that are defined in the sudo files. And those command definition had to be listed as a separate command. So I think it's not mentioned here. But each of this is a command, and then you can group commands to create role definition. Role definition. So that the role definition can then be associated with the actual user. So if you see here, this is the role assignment. So you can see that Nova user has a particular role which is named as Unix Nova root wrap. Unix Nova root wrap is a name that we gave. But then the Nova root wrap basically corresponds to this. So if you see the last one, Nova root wrap, this is the command it corresponds to. Effectively, it's just like adding a sudo entry, but instead you're doing it in this particular Central Access Management server. Sorry. So this is effectively the final outcome. So we could get OpenStack services running with central user instead of local user. And even if you're using an environment which does not use a Central Access Management server like Centrify, you could always have somebody wanting to use your operating system configured to a LDAP. So we all know that OpenStack can be configured to use LDAP server directly, but then your systems in your data center itself could be configured in such a way that it directly is configured to LDAP and not to your local OS. So the challenges I mentioned here is very similar to that environment as well. So final outcome is we could get OpenStack services running with central user. And we also found that if you use local user, your file permission are mapped to the local user, but if you configure it with a central access management server, your log files, your config files, everything actually gets mapped to the users which are in your central server. We got the non-sudo utility, which is DZDO invoked instead of sudo, and that was a great personal achievement, I felt, because we were really wondering how we would get it working, and even though adding a link, symbolic link seems like a very, very trivial thing to do, we didn't expect that to work, but it actually worked. So all the sudo calls, it got routed to DZDO, and DZDO could actually go and talk to the central server, and because we had all the users already loaded. So we had the users loaded even before OpenStack was installed. So first step is loading all the users and then going ahead and installing OpenStack. So when OpenStack is installed, it sees that, hey, this user is already there. Hey, this NOAA user is already there. So it doesn't go and create a NOAA user. Instead, it uses the NOAA user, which is already defined and available. And the best thing is we did not have to make any changes in OpenStack, and it works with Oslo root trap if you're using a very old version. So the takeaway is security-conscious customers are moving towards advanced identity systems, which means that today you could be working on an environment which completely is a local environment, which has sudo, which has local users, but it's not far away when your customer or you have a need to move towards advanced identity system. So Centrify is just one of them. There are a lot of others as well. And OpenStack can be installed, so that's our finding, and we were able to get that working. There is no official documentation for this work yet. We have not documented it yet, because the primary challenge was we tried it with Centrify trial license, and the license got expired, and then we could not proceed with the work after that. Yeah, so that's all I have. So I'll pause here and check if you have any questions. So it was perfectly clear. Okay, I'm glad to know that. Thank you very much.